Welcome back to Ganesh Institute. I'm hoping that you have already watched another video which was based on Napier Bones for multiplication. Now if you have watched it already, this is another section where we are discussing how we can find out the square roots using Napier Bones. So let's get started. See, so far we know that Napier Bones is like rod-like structure where we have first bone, this rod, as multiplicative rod, index number. You can see 1, 2, 3, 4 up till 9. Then rest all other rods are for multiplication where we write the number in diagonal form. For example, if we are saying that 8 3s are 24, so we will write this as a divided cell, okay, diagonally divided cell. Here you can see 6 times 2 is 12, right, diagonally divided. So what is different if we compare the multiplication with the square root extraction? So here we have another rod, a set of rod, which is called square root rod, okay. In this square root rod, we have in the last column the index number, of course, 1, 2, 3, 4 up till 9. Then because you know that square root, if I'm asking 12 square is what? You will say 144. Because the power of 2 is involved, that's why we are considering even number. So just double this index number. So 2 to the 4, 2 to the 6. So it is simply 4 to the 8, 5 to the 10. You are doubling it, the index number. So second rod, this is first rod, which is index number. Then second rod is of even number. And third rod contains the squares of index number in diagonal form. So for example, let me change the color of the pen. This is 1. So 1 square is 1. 2, 2 square is 4. 3, 3 square is 9. 4, 4 square is 16. 9, 9 square is 81. Okay. Now let's see how these three additional rods can help in finding out the square roots. See, let's suppose we have to find out the square root of 1849. There are many methods. You can do repetitive subtraction, long division, prime factorization, and so on and so forth. But what we are using here, first step for that is just pair the numbers like digits from backwards. So if you see 1849, so 49 in one group and 18 in one group. If it would have been 144, 44 would be our first group and then 1 is the next. Okay, so first step is to distribute the terms and group them together in the pair. Now, what is next? Here you have to write the index number. Okay, how? Let me tell you. So I'm making the rod 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I should have created the columns first. Okay. Now what is next? So this is the index number. Then for the square root, we have double of it. 1 times 2, 2 times 2, 3 times 2, 4 times 2, 5 times 2, 6 times 2, 7 times 2, 8 times 2 and 9 times 2. Oops, this should be 18. Correct. Then what is next? Tell me. Yes, perfect square rod. Correct. Just bear with me. It is very important to draw the table very properly, very carefully, because if the structure changes, the pattern changes, and then it's just a flop show. Okay, now square root in diagonal format, right? Tell me, 1 square is 1, then index number 2, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, right? So this is usually a multiplication table. Now what I'm supposed to do? You have to see the first row, 18. Now see the perfect numbers table. You have to find out the number which is equal to 18 or less than it, the largest number. So you can see 16 is the one, correct? This 16 is the one, because if we take the next number after 16 is 25, which is greater than 18, we don't want that. So 16 is the largest number which is lesser than 18. So I'm writing here 16. But which index number is it corresponding to? 4, correct? So just write 4. This is the first digit of your square root. Okay? Now the next step is you have to subtract it. 18 minus 16 is 2, and copy this 49. Okay, what would be the next number? For that, you have to take the even number of this index number. 4 times 2 is 8. Correct? So this number, you have to consider the table, multiplication table of this digit which you have got, 8. So draw here the multiplication table of 8. Okay? Getting my point? Okay, so multiplication of 8. 8 ones are 8. 8 twos are 16. 8 threes are 24. 8 fours are 32. 8 fives are 40. 8 six are 48. 8 sevens are 56. 8 eight are 64. 8 nines are 72. Right? What is the next step? Again, you have to look for this number 249, the largest number which is lesser than 249. But how? Now you have to consider this one, and this one. Not this one. Only these two perfect numbers and the multiplication table which you have got. So what are these numbers? You can see. If you have to consider these two, like 8 and perfect numbers, now these are forming lattices. So, for example, if I'm considering this, what is this? 7281. So what is its value? It is 1, 8 and 2, 10, 7 and 1, 8. So its value is 801. Getting my point? So this is how you calculate the value. So here, when you have to find out the value of 249, how can you do so? Just look at this. What it will give you? This is the lattice like this. Here you have 2, 4. Here you have 0, 9. So what is it? 9. 4 plus 0 is 4. And this is 2. 249. Correct? This is the one. So tell me, this 249 you will write here. What is happening? So this 249 you will write here. And you will get 0. So you get 0. So you've got your square root number. So what is the next index number which you have to place here? This 249 is corresponding to which index number? 3. So just put 3 here. So 43 is the square root of 1849. Is it clear? It's a bit complex, but as soon as you start practicing, you'll get it right, okay? Let's move on to another example. So you can see now we have a bigger number. How can we solve this using the same procedure? So we will group this together, starting from backwards. Now 4 is left without any partner, so leave it, let it be. Now what are we supposed to do? Firstly, the index number up till 9, then the even number, double of this, 2 times 1, so 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. Repeat the same procedure, right? Then what we need? The perfect numbers. This is the square root rod, correct? So we need perfect numbers, but for that we need the pattern in the form of what? In the form of diagonal, right? So let's draw it properly. So just jot down the numbers. Okay, here we have square of 1, which is 1, square of 2, which is 4, then square of 3 is 9, square of 4 is 16, square of 5 is 25, square of 6 is 36, square of 7 is 49, square of 8 is 64, square of 9 is 81, right? So this is the square root, like perfect square rod. Now, what we need? This is 4. We need the number, the largest number, which is either equal to this number or lesser than this. So we have to look into this table. We can find 4, the exact number, which is at which position in the index number rod? 2. So this 2 is our first value, first digit of the solution. Like in the square root, this is the first digit. So we get this 4, we subtract it. So what is left? 6656, right? Now, what is the double of this? Which is 4. So we have to write the table of 4, multiplication table of 4, right? So for that, again, make the table, okay? So how can we do that? Again, that diagonal value form. Just bear with me. So we have here 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 4 six are 24, then 28, then we have 32 and 36, right? Now what we need? We need 66 by grouping these two. So we need 66 or the next lesser number. How can we find that? See, you have to do lattice multiplication. So for this first index number, we have 0, 4 and 0, 1. Consider these two rods. So what have we got? 1, 4 plus 0 is 4 and 0. So 41. Next, from second, we can have what? 0, 8, 0, 4. So it is 4. 8 plus 0 is 8. So 84 is greater than 66. So let's keep it 41. And 41 we got from Which value? 41 is at first index number. So next digit in the square root is 1. Okay. So now what is the double of 1? It is 2. So we next need the multiplication rod of 2. Okay. 6 minus 1 is 5. 6 minus 4 is 2. We need the lesser number or equal to this 2556. Okay. So make this table again. What we need is the multiplication table of 2. So 2 times 1 is 2, 4, 6, 8, 10, 12, 14, 16 and 18, right? Okay. Now we need 2555. That means again, this is 6, right? This is 6. Okay, we need 2556. So for that again let us multiplication. But now this time we will consider all of these 3 rods. So because we need at unit digit 6, so let's go for 4 or 6, because we know that 4 4s are 16 is having 6 at unit digit, and 6 6 are 36 again having 6 at unit digit place, right? So okay, let's do it. If we go with 4, what is the lattice which we are having? We have 3 rods. So here for 4 we have 1608 and 16 again. So it is 6, 8 plus 1 is 9, 6 plus 0 is 6 and 1. So 169 is lesser, but still let's look at this. The number, the digits at 6th position also. So what have we got at 6th position? We have 24, then 12, then we have 36. Okay, 6. This is 6. 3 plus 2 is 5. 4 plus 1 is 5 and 2. That's it. So we have got this 2556, which gives us remainder as 0 at 6th position, 6th index number. So 216 is its square root. So I'm hoping that you are clear with the Napier bone method. You can use Napier bone toolkits as well to find out the answer. Now the last question is for you. So again, just try to group them together. This is the first step. Find the index number from the perfect square rod, and then keep going on with the multiplication rod of the index number which you got, and then multiply it, because we need even number for multiplication table. Okay, like the double of it. So if you have got this concept right in your head, then please don't forget to like, share and subscribe our channel. Till our next video, take care of yourself. Bye bye.